At the same time, this is called initializing a variable. And so we initialize the speed variable to be at 5.0 for its speed. So what you're going to do is you're going to create your very first variable so we can store the speed that we want our vehicle to move. Make sure that you use the keyword public so that way we can see this variable outside of this class and use it. Use the keyword float, that way we know that our speed variable is a number that uses decimals. We can choose what we want to name our variable, so we'll name it speed, and then we use the equal sign to assign or to set our speed to be 5, and then make sure if you use the .0 just to add an F at the end, so that way our program knows that this is a decimal number. And then in your update method, change the 20 to speed and test your game. And then while your game's playing, if you select the vehicle and then you go into play mode, you can actually left click on the speed under the player controller and drag it, and you can change the numbers by scrolling side to side. Now it's your turn. We've added a variable to our vehicle. So if you select the vehicle in the inspector, you can see that speed variable under the script. Now when we press play, we can actually click on that speed variable, drag it, and we can control the speed. So we've got some good control, but our camera is still locked in the same place. So we want to make it so we can actually follow the player as they move back and forth. To do that, we'll create a new script. So underneath your assets folder in your project window, if you go down to scripts, right-click on scripts, create a new C# script. We're going to name this script follow player because this will attach to our main camera, and the behavior will be that the camera will follow the player. Make sure you name it correctly with the capital F and the capital P with no spaces. And then we're going to left click on follow player and drag it onto our main camera. Now, if we click on our main camera in our hierarchy, you can see the follow player script has been applied as a component. So now we're going to open our follow player script by double clicking on it. So now our script has opened in our IDE. And what we're going to do is we're going to use public variables, but in a very different way this time. So what we can do is we can actually get a public variable. And what we're going to do is we're actually going to use a class or a type, in this case, a game object. And so, like I said before, things like our obstacle or our vehicle are game objects in our project. And so actually, we can get references directly to our different game objects like our player. If we check in Unity, you can see now on our follow player script, it's added this line of code. If we select our main camera in the hierarchy, you can see that the follow player script has this player variable, and it's looking for a reference to a game object now. And so in fact, we can actually left click and drag our vehicle from our hierarchy into that box, and now our player variable is tied to our vehicle. This is one way that you can get a reference to an object in the scene for another object to use. In this case, our main camera to use the vehicle. So variables can be used in really powerful ways, not just to store numbers, but to store references to other things that already exist in our game. Now what we're going to do is we can do a really interesting thing where we can actually get the transform. So this gets us the current transform component of the game object that this script is applied to, in this case, our camera. So we get our camera's transform, and we can actually just get its position overall. And so this will give us the X, the Y, and the Z of where our camera currently is. Now, we're going to use that equal sign, that assignment operator. We are going to set our camera's position. Now that we have a reference to our player, we can actually use player. The player also has a transform component, and we can actually get that position from the player's transform component. And then if we semicolon to end our statement here and make sure we save, so now our camera's position will be set to the player's current position. So now, if I press play and you watch in the scene view, watch our camera and our camera should be set to the position of our vehicle. There you go. Kind of works. It's underneath the car, which is close enough to what we want for now, so we can watch it as it drives down the road, runs into the different boxes. Cool little perspective. So what you're going to do is, in Unity, make sure you go to your project window, right-click on Scripts. You're going to create a new script, a C# script. You're going to name it Follow Player, capital F, no space, capital P. And then you can left-click and drag it onto your main camera, or just add it as a component using that little handy button in our inspector for the main camera. You're then going to open up the follow player script by double-clicking on it. In our follow player script, you're then going to create a new variable. This time it will also be public, but this time it'll be a game object variable. So that will be the type of variable that we're creating. and we're going to call it player, so that'll be the name. And then in our update method, add this line of code. So you get the camera's current transform position, and you're going to set that to the current position of our player's transform component. And then last but not least, a really easy step to forget is make sure you select your main camera in the hierarchy. In the inspector, you can see on the follow player script, there's a player variable that has no game object attached. So you're going to make sure you left click on the vehicle in your hierarchy and drag it into that box. So then your player variable is assigned to the vehicle in our scene. So then when you press play, you can watch it as it drives down all the way down the road. Now it's your turn. Our camera is now positioned. Unfortunately, it positions underneath the vehicle, which is an interesting perspective, but not exactly what we're looking for. We actually want to create the same effect that we have in our camera here in our preview. So that way we're following behind the player instead of underneath the vehicle. So we'll change that perspective using some of our code. And then what we're going to do is where we're actually setting our camera's position to our player's position, this is actually where we're going to add to our player's position so that we can offset our camera above and behind our player. Fortunately, we already did some of this work before. So luckily, the player vehicle is at 0, 0, 0. And then what we did with our camera is we actually put it at 5 on the Y and -7 on the Z, so it went up and then it went behind our player here. So we can actually use those values to be able to reposition our camera behind the player when the game starts. So using our update method, since we're constantly keeping track of the player's position, we want to add, in this case, we just use a plus sign like you would on a calculator, and then we should add, I believe it was 0 and up 5 meters and then back 7 meters, so -7. So that doesn't seem to work. So let's see. I believe the problem is, so in fact, our player's position is giving us a vector 3. And here, although this would make sense in our heads, this doesn't make sense to our computer at all. Our program is trying to add some statement that doesn't exist, and is trying to add it into our vector 3. So what we actually need to do is we need to add two vector 3s together. So we actually need to create a new vector 3, and we're going to use the keyword new because we're actually creating a new vector 3 instance. We're not creating a vector 3 variable that we're storing or saving. Since this is just temporary, we use new vector 3. And so now this will actually create a new vector 3 just for this line of code that'll have the values of 0 on the X, 5 in the Y, and -7 on the Z. Last but not least, we're going to add a comment to our code. So we're going to say offset the camera behind the player by adding to the player's position. Now we make sure we save. So now if we test our game, we should see that our camera is just following the vehicle. Awesome. So now we have a much better view of where we're driving and where we're going. So what you're going to do is in your camera's position, where you set it to be the player's position, you're just going to add a new vector 3 with the values of 0, 5, and -7. Now it's your turn. Now, our camera is positioned perfectly behind our vehicle as it drives down the scene. What we're going to do is we're just going to clean up our code just a little bit to make it easier to understand. In our follow player script, I mentioned that it's really bad to have hard-coded values. So we're actually going to take this vector3 we've created and create a variable for it. So this one will make a private variable, so it can only be used inside of this class. So I'm just going to use the keyword private here so you can see how it's used. Very similar to a public variable. And for this, because we're making a vector3, we need to make this variable a type of vector3, and we'll call it the offset. Now we set this variable to be this value here. So in fact, we can just cut by Control or Command X with the code highlighted, and then we go to where we had the offset and we paste with Control or Command V. So now our offset vector variable is being set to that new vector that we made before with our offset position already added to it. So now, in our update method, we can just add where we removed that bit of code, the word offset, and because offset is a vector3 being added onto a vector3, then we can set our position properly. Make sure you save, go back into Unity, and press play, and you should see that nothing has changed, which is exactly what we wanted to happen. So what you're going to do is in your follow player script, you're going to create some of variables of your own. You're going to make a private vector3 variable called offset, and you're going to initialize it by assigning it that new vector3 offset that we had created down in our update method. And then you're going to remove that new vector3 line and just replace it with the word offset. So that way, it's always just using the offset variable, and if we ever need to change our offset numbers, we can just do that here at the top of our code. And then just make sure that you press play and test to see that it's working exactly like it should. Now it's your turn.
Mic. Oh, there we go. Now the mic's working. Yeah, I don't know why. Don't know why that triggered. That shouldn't have triggered like that. Bit annoying, but yeah. Oh my god. Well, that kind of triggered unexpectedly. Anyway, we're going to continue with our coding. The main 2. So the this course is free. Whoops. This is free to learn. It's Unity Learn. It's a bit out of date, but it will do. Oh, we forgot to put offset. Okay, that's probably why it wasn't following the vehicle. Main. So need to add the plus and then offset. Control save. The code didn't show up, but I'll show the code here. So we've got that offset. And now we test it out. Let's save the project first. Let's see how this goes. So that is working fine. Just so you know, I do have a game in mind that I want to. So Conter Sam, I do apologize if I said that name wrong. What are you trying to make? So I'm not really trying to make anything particular. I'm literally learning Unity CSharp. And obviously I'm using the free guide that is available to anybody who wants to learn Unity CSharp. Basically, I'm trying to learn to code a Unity game because I do have a game in mind at the back of my mind that I want to build. But for me to be able to start doing that, I need to learn the C-sharp's variables, pretty much everything like this, because I'm autistic. I'm not so intelligent like other autistic people. I struggle to learn sometimes, especially when you don't put syntaxes in the right place. And then it just messes up and gets confuffled. I did used to play Roblox years ago. I did learn Lua, but now I want to try and be able to use C# for the game that I have in mind. Obviously, it might take a while for the game to be developed because myself will be a solo developer. currently. So I'm just trying to learn the C# coding program so I can try and memorize what goes where. There is also let's have a look. Let's go here. So I'm going to put let's see. Let's put this on screen. So at the moment I think we're currently in the middle of welcome to the to Unity Essentials. I'm not gonna do anything just yet with AR. I'm not planning on doing anything VR related just yet because I'm still new to coding. Create with Code, you've got like a beginner's course. At the moment we're doing pedal to the metal, or metal to the pedal. And then once I've done that, once I've learned the basics of Unity code, I may then think about going into, like, obviously following these steps, especially for the beginner courses, to learn. That's obviously advanced. That's going to be way out of my league at this moment in time, at the current state I am at. That does look a bit simpler, but can be a little bit difficult, depending on how complicated the game's going to be. So yeah, that's what I'm currently doing at the moment. That is the wrong screen. It should. Yeah, there we go. So yeah, that's where I am at the moment. I'm learning Unity C#. So we'll leave that on and we'll go to main screen 2. We've done that step. Smooth the camera with late update. So we're going to do this one now.
Okay, now that we have our camera following our vehicle properly, you might notice that there's a weird effect happening with the vehicle itself where it's kind of stuttering back and forth. And so we can make one small change to our follow player script to make our vehicle move super smoothly. Now, essentially what's happening is in our update method, our vehicle and our camera are both moving at the same time. So sometimes the vehicle might move first and then the camera might move, but other times the camera might move and then the vehicle will move, and so it creates this stuttering effect. A simple thing that we can do with our update method is change it to late.
What I will do is, if I come all the way up here, let's open that in another tab. What I'll do, Conter Sam, I do apologize. I'm just going to say Sam. It's going to be easier for me. Are you still planning on wanting to learn Unity? If so, I can link this link into the chat, live chat, and you can follow it after the stream or during the stream. Just have a brief look through of what there is. Yes, that's my real name at the top there. They should have. You can. I can't remember how, but you can change the language of the what do you call it? The HTML website. I just can't remember how to do it because I've never needed to do it often. So I'm going to use my handy dandy streamer bot chat here, and I'm going to paste that in. It should come up on stream soon. There you go. So if you do want to learn Sam, then obviously I would highly recommend following that link. It is free. You don't need to pay for anything. There are some plans you can go for. There is there's one for personal, which is free, and then there is another one. I can't remember another one. So we're going to jump back down to the smooth camera. Oh yeah, also when you first click on that link, I would highly recommend creating a Unity Learn account. That way, when you're doing something, it will track your progress. So if you exit out of it by mistake, you just simply, open up the web page again, log back in, and it'll the ones that are green are the steps that you've completed on the guide. So at the moment, as you can see, I'm on guide 5, which is smooth camera, and I literally just click that and it will take me straight to where I left off. There is a transcript that they have here, so they don't have German for some reason. I don't know why. I would have thought they would have had German in there, but obviously not. But das ist gut. I know a bit of German. I just can't speak full German. So I'm going to continue with this guide, and and then I will do what this guy's done. There's 3 steps that they tell you at the very start. The 3 words you're going to learn is watch, then do. Watch, then do. So what I'm doing is I'm watching the guide video, then I'm doing. Obviously I'm on a dual, I have dual monitors, so I've got the guide on my second monitor and the Unity project on my main screen. So I can skip back and forth if I need to, if I've missed a little bit. But yeah, it is interesting. So I'm going to continue watching this, then I'm going to obviously then do. So I do apologize if it's not in German. I can't really do much about that because my main language is English, you see. So even though I can say das ist gut, Scheiße, or Scheiße heißen, or that type of stuff, but I just can't fully speak German. So yeah.
Late update with a capital L. Make sure there's no space, so it's all one word. And with this late update method, essentially what it will do is update after our update method happens. So if you remember, for our vehicle, it's moving through the update method, constantly moving forward, and then late update is called, which will then move our camera after the vehicle is moved. So if I save this script using Control S or Command S on a Mac, head back over to Unity, and then test out our script to see if it works, we'll press play, and you can see now that the vehicle is moving much smoother because of that late update method, where the vehicle moves first, and then late update happens, making the camera move to follow the vehicle. So what you're going to do is head into your follow player script, and where update is, we're going to change that to late update with a capital L and a capital U, no space, so it's all one word. Once you've changed update to late update, make sure to save your script using Control or Command S. Head back into Unity and test out your project using the play button, and you should no longer see your vehicle stuttering in your camera frame. Now it's your turn.
So the other thing as well is they have this box down here where it tells you what to change. So we need to change that void line above the transform dot position. So if I head over to code, see if streamer bot will actually listen to my voice. Main. The main reason why I pause is when I'm talking, StreamerBot is going to log it, but if I'm talking and then say a command, it will just mess up. So every time I go quiet, that's just me going into the voice control and its settings and just stop and just using the stop listen button. But so up here, we are changing that to late update. Late update. I've already controlled left controlled an S to save. If I move that over there, whoopsies. Go here. Code. So that command is meant to turn off the code screen so you can see Unity after. So I'm saving the project just in case anything does happen. And we should now have a smooth camera movement with the vehicle, just like the guide said. So we'll go ahead and we'll test it out. See, down here it's a lot smoother now and it's not stuttering. Obviously I know you've not long just joined, but there's already been some things I've already changed. Don't worry about that. That is just because there's nothing stopping it flying off the road. Obviously this is a prototype 1. Main 2. When you start off with the project, at the very start they let you download a zip file. That zip file is the prototype that I'm using for this guide. You're basically learning CSharp, but also you could say learning a bit of physics as well in Unity. So smooth camera, once you've done it, you can go down here, mark as complete, and then now we are going on to edit the play mode, tint color. So this is 1.3 high-speed chase guide. So I'm going to mute my mic. The reason why I mute my mic, Blue Roblox, hello. The recycle, hi, welcome. The reason why I mute my mic is so when the video is playing, well, the guide video in the background is playing, it's not coming through the mic, so it's not like echoing. So that's why I'm quiet when the video is playing. So don't worry about that. That's just so I don't have multiple background noises going on at the same time. So we're going to go and watch the step 6 and we'll go from there. I'm going to learn at least a bit of Unity in the weekend. Blue Roblox, that's good. I have actually, what I'll do, that link I posted in chat. Let me open up time. No, mute that. I'm going to pin this, so it's going to be at the top of the channel. So you guys, so if anybody is chatting away, at least it's still going to be visible. So anyway, we're on step 6 of learn pedal to the metal. is what it's called.
Our camera is now well set up in our game to be behind the player, and we even added in some variables to make our code more organized. Now we're actually going to fiddle around with our Unity interface again, just like we changed the layout, but this time with a very helpful tip to know when you're playing your game. So you can see when you play the game, your interface goes from a light gray to a dark gray, which is helpful, but not entirely visible. So I'm going to show you a cool little trick that I do so it's really easy for me to know when I'm in play mode. At the very top left of Unity, there's an edit button. If you're on Mac, there will be a Unity button and then you click Preferences. From my edit menu, I have a Preferences option as well. Now, in our preferences, we have all of these different options. Right now we're on General. There's one down here called Colors, and specifically, there's an option here called Play Mode Tint. So this is actually what controls the tint of our interface when we're in play mode. So if I select this by clicking on it, you see it brings up a color picker. So you can pick colors yourself, you can move it around, you can change the opacity so that it's more clear, or if you want it to be really dark and really visible, entirely up to you. So I have a setting that I like to use, so I'm just going to type in values for myself. So 157, 194, 239, and then we'll make this like 150. So now I should have a fairly transparent light blue. So I can close out of my preferences. You can see that it actually saves it immediately when you set that color. Close out of the preferences. Now when I press play, you should see a bluish tint pop up over all of my window. So that's super helpful. So now I know when I'm editing values, if I'm in play mode or if I'm in my scene. And so that way I don't accidentally change something that just gets reset and then I don't remember what the value is. So very helpful tip, just something to make your life a little bit easier as you're testing your game out and trying to figure out why, for example, if you click on something, it's not moving or whatever. So what you're going to do is in the top left of your editor, you're going to see an edit or a Unity button. Click on that. Go down to preferences, click on that. You'll see this preferences window pop up. You can click on the colors option. Under the colors, the very first one, under general, should be play mode tint. If you click on that, you can select different colors, you can change the opacity, and then when you exit, it saves your color. You can exit out of to use. So I'm just going to type in values for myself. So 157, 194, 239, and then we'll make this like 150. So now I should have a fairly transparent light blue. So I can close out of my preferences. You can see that it actually saves it immediately when you set that color. Close out of the preferences. Now when I press play, you should see a bluish tint pop up over all of my window. So that's super helpful. So now I know when I'm editing values, if I'm in play mode or if I'm in my scene. And so that way I don't accidentally change something that just gets reset and then I don't remember what the value is. So very helpful tip, just something to make your life a little bit easier as you're testing your game out and trying to figure out why, for example, if you click on something, it's not moving or whatever. So what you're going to do is in the top left of your editor, you're going to see an edit or a Unity button. Click on that. Go down to preferences, click on that. You'll see this preferences window pop up. You can click on the colors option. Under the colors, the very first one, under general, should be play mode tint. If you click on that, you can select different colors, you can change the opacity, and then when you exit, it saves your color. You can exit out of preferences, so then when you play your game, you can see when you've entered play mode, which is really handy. So, now it's your turn.
main. Oh, yeah, I forgot I turned off the main. Okie dokie, lemon spokey wokey. Blue Roblox. Did they fix the Unity update though? I don't know what I don't know what fix they were meant to have done. I've only just started using Unity today, so the current version I'm using is let me pull it up on screen for you. If it works. There we go. The current Unity I'm working with is I'm using the version 22.3.10 F1, and that's the current platform for me. You can install other editor versions. See, there's one here for 2023. This one doesn't have. I don't know if this is part of the LTS, which is long-term support. So I don't know. But I am just using 22.3.10 F1 version. I don't know what Unity 5 is. I don't know what update that one is. It's probably 23 something, the one we've just seen. But I think that's something later on that I might upgrade to maybe. Right, so let's go here. Go up. No, we need Unity first. So edit, preference, colors. Play mode tint. I'm going to skip back the video a little bit so I can see the values. So we've got 157, no, 157, 194, 194, 239, 239, 150, 150, and that should be fine. I think we just close out of it now, I'm assuming. Then play. Yep, there we go. So we've got that one done. Now we will go main 2. We'll go back here, and then we will mark as complete. Lesson recap. Will be muted again for this video. Just letting you know.
So our game is in a pretty good place now. We have our camera that follows behind the player as it's offset. So that's some cool functionality that we've added. We've also gained a lot more programming knowledge. In our follow player script, we learned how to use our first public variable, in this case, so that we can actually attach a reference to our player in Unity. We learned that variables also don't have to just be numbers. They can be game objects, or they can be vector 3s. They can be of whatever type they want, as long as you make sure that you assign the same thing to the type of variable that you have. So we have a vector 3 offset, and we assigned it to a vector 3. We learned about the difference between access modifiers, like the public and the private keyword, so that we're able to interact with and use these variables in different ways inside and outside of our script. We also learned how to initialize our variables. Now, in the next lesson, we'll add our last lines of code so that we can really control this player as they drive down the road and help turn around all these different obstacles so we don't just keep pushing them all the way down. See you in the next lesson.
Blue Roblox. Yes, I try to be nice. Also, I want to thank you for subscribing. I don't have the alert boxes up yet because I'm using StreamerBot, so it tells me if I add it, it might say something. Widgets, alert box. Oh, well, it's on screen. No, not fit to screen. That's going to be way too big. Reset. Transform. Center on screen. And then if I open up Studio, no, streamlabs.com is what I'm after. No. Dashboard. I don't really. Look, I'm not an API developer. Stop taking me to that page. Where is it? Alert box. Nope, I already know that. It should be. Where do I find it? Where do I find it? Hello? There should be no, not Ultra. I should have recent events. Here we go. It should show up on here. So yeah, that worked. That's all the events I've got at the moment. So we've camera follows the vehicle down the road at a set offset distance. New concept and skills, variables, data types, access modifiers, declare and initialize variables. Next lesson is going to be something different, and you get this screen as well. So as you can see, we're currently on Unity Essentials level 1. That will probably be a different one. Then we've got audio levels. Then we've got systems design. I think that is mainly for like making like software and stuff. I might not get into that straight away. So now we are heading to lesson 1.4, and we are going to watch the overview.
The vehicle in our prototype is currently a very low-end, very dangerous self-driving car. You click run and the car rockets off on its own, crashing into every obstacle along the way. Not necessarily the kind of car you'd want to be a passenger in. So it's about time we let the player step into the driver's seat and take the wheel. By the end of this lesson, the player will be able to control the acceleration and direction of the vehicle using the arrow keys on the keyboard. The vehicle should move forward when the up arrow key is pressed, and backwards when the down arrow key is pressed. Luckily, Unity has an entire input system set up to help us do exactly that. When you press the up arrow, you get an input value of +1, and when you press the down arrow, you get an input value of -1. So let's say we set the vehicle speed to 10. All you have to do is multiply that speed by the input value and you're good to go. When the player presses the up arrow, it'll multiply 10 by +1, giving you +10. moving that vehicle in the positive forward direction. But if they press the down arrow, it'll multiply 10 by -1, giving you -10, moving the vehicle in the negative backward direction. Then you can basically use the same type of system to rotate the vehicle. You multiply the rotation by a positive value if they press the right arrow, turning the vehicle right, and multiply by a negative value if they press the left arrow, turning the vehicle left. Just some simple multiplication, and you've got full control of this vehicle. So to make all that happen, I'll see you in Unity. Our vehicle drives down the scene now, and when we press play, we have this nice tint to show us that we're in play mode, and we have our camera following, but right now, we still can't really control our vehicle. It just drives all the way down the road, just running all these obstacles over, pushing them off, and then eventually it gets to the end of the road, and then it just falls straight off. That's just because there's not an end there, but we need to be able to control this vehicle's movement. So first we need to be able to move our vehicle so that it avoids the obstacles. If we open our player controller script, we're going to need a way to control our vehicle to move left or right. So we should probably just use a variable to do that, since we know it's probably pretty bad to just use a random number. So good to think ahead in general. We're going to make this a public variable so that we can control it just like we did with the speed. It will also be a float because we'll be using decimal points. And then we're just going to call it turn, lowercase t, capital S for speed. So you can see here turn speed has different capitalization. So this is a very standard, what is called a naming convention when you're programming. So for variables, we often use lowercase letters like speed, turn speed, even transform is a variable, to be able to very easily see when we're using a class or when we're using an object, when we're using methods, or when we're just using variables. Now we want to be able to move our vehicle left or right, so we'll do something similar to what we did with our transform.translate. Instead of a vector3 forward, we can actually use, there's a whole bunch of other options for vector3, so we can actually use like right. So this will move our vehicle in the right direction. Again, we're going to multiply by time.delta time, because we want to be able to update this position over time instead of once every frame. And then we multiply by that handy turn speed variable that we made before. So now in our game, if we take a look down at our game view and we select our vehicle so we can see the values, if we press play, nothing's happening. Well, that's actually because we're multiplying by a 0. So actually, if we click on turn speed and drag it to the right, it'll actually start turning right if it's positive. If we go to the left, it'll start going to the left because the value's negative. So easy way to see how we can move our vehicle left or right. Now that's great, but we'll need to be able to also control it as well. But first, what you're going to do in your player controller script, create your own turn speed variable. We'll make it public so we can play around with it in the editor. Make it a float because it will be a decimal value. And then in your update method, we're going to add another transform. This time we're translating with vector3 right. So we're using our right vector. And then we multiply it by time, so that way it updates over time instead of every frame. And then we multiply it by our turn speed variable. So then, when we play, if we click on our vehicle in the hierarchy, we can actually click and drag the turn speed so that it moves left and right. Now it's your turn.
Main. code. Oh god. Ow. Wow. Ooh, that was an unexpected cough. At the top of the player controller.cs, add a public float turn speed variable. Yeah. Void update. Am I missing anything? I don't think he added another script. Let me have a look. So, player controller. Mono behavior. Public. Did he add another script? No, because we're on player. So, I think we need to add that. Oh, hang on. No, we put it in the wrong script. No, we don't want to do that. Nope. No, because that is player controller, not follow player. Ooh, that would have been bad. Bad. File. Player controller. Here we go. Speed. Then we've got public float turn speed, and then down here we've got the delta time. Yep. Control S to save. He's on that line. Now he's moved out to that line. We go transform dot translate vector 3 dot write that by time dot delta time speed. Control save. See how that works. Can you explain what you are doing right now? So at the moment, yay, I am just basically learning Unity C#. I am following a guide. We go to main 2. Okay. Don't worry about that. That is my streamer bot. That is what I'm using to call the video. But I am following the guide. This free guide, I am following it step by step. It's pretty simple because it obviously tells you the basics and then tells you what you need to change or add. Then once you've done that, once you've done step 1, you would go down and obviously mark as complete, which then you would move on to the next. And basically what you're doing is you're just building up your script, C#. So that's what I'm doing. I'm just trying to learn Unity Sharp, because I do have a game in mind that I want to develop. It might take a bit of time for the game to actually come out, and even a demo release is because I need to build it up from the bottom up. Then I've got to remember the variables, integers, and what is meant to happen at what time. Because I am going to be a solo developer for the game that I've got in mind. Just a short brief. It is going to be a simulation game, but I'm going to like I'll add like a tutorial to the game so people can understand the game when it's in development. When I do start building that game though, I am probably most likely going to stream it on this channel so you can see my progress. Then later on I might set up a roadmap of the development and try and keep everyone updated if you do decide to follow the project. Because I know for a fact, for me to be able to upload it to Steam, I need to pay a small little fee. So that's going to have to hold off for a bit, unless there is other game platforms out there where I can upload a demo when it's at its demo stage for players to try out. There will be also a demo in the demo, but the demo will be the tutorials will be expanded in maybe like a pre-alpha state or something like that. Because the game, I can see the game is going to be quite big for the game that I'm planning on developing in the future. And for me being a solo developer, it's probably going to take years, maybe months, depending on if I can remember what bits of the code goes where, pretty much. If at any point I do tend to forget where something goes, I will revert back to this guide that I'm using currently now to give me a bit of a boost of a reminder. So yeah, I'm just pretty much at this stage where I'm at. I'm just learning Unity C#. That is all I'm learning at this moment, because it's been a long-term idea for me, but I've just been struggling to try and find ways to be able to do a course, to learn how to do it, to develop a game, because I mentioned further back in the streams, further back in the stream I meant, I'm autistic, so I sometimes struggle with certain things depending what the situation is. I'm not very intelligent, not like most of the autistic spectrum people out there. Some of them have a brain that can literally just do something without even knowing what to do. But for me, it's a little bit difficult because I have learning difficulties as well, which comes under ADHD. So I've got autism and ADHD. I do have what do you call it? I do have a segment of myself where I have OCD. So if something isn't right, I will continue to try and do something to make it right. If something is to move from where I left it, I get frustrated because I know I left it there and it's being moved somewhere else. So I would move it back to where I originally had it. So yeah, that's what we're doing at the moment. It's quite interesting. I am sort of learning a little bit, but if I do end up forgetting, like I said, I'm going to revert back to this guide. This is a free guide. You don't need to pay anything. There is 2 plans you can go for, and they're both free. But if you're going for like a professional course, I think it's 1,700 and something euros or something like that. That's what I saw, which is way out of my pay grade to even do that far. So yeah, and obviously before a game release as well, I may think about setting up a Kickstarter page when the development to my game starts getting on the roll. So that way, if you want to support the project, you can feel free to do so. And then once the game is at its stable branch, there will be a possible chance that I'll end Kickstarter, but when I work on the credits at the end of my game, I will make sure I will put the backers down on the what do you call it, on the credits, so you get credited for the support of the project. It is going to be a fairly long, I know it's going to be a fairly long project. I can see it happening. It's based off of a game I used to play on Roblox, but I'm gonna try and not make it as the same as the game on Roblox. I'm gonna try and see if I can alter it a little bit. But yeah, so that's where I am at the moment. So yeah, let's continue. Main. So have we done what we need to do? Turn speed, yep. Transform, translate, write, yep. Okay, I think we're good. I think we're good on this part. Code. Okay, so if we go in and we play, it should work. We need to select the vehicle in the hierarchy for it to work. At the moment, we're reloading domain. Oh God, no! What are you doing? Whoops. Vehicle. Woohoo! Right. Right. We need to. No, 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 no. Oh bugger. I don't know if I've done anything wrong, but I don't think I have. What if we move the vehicle over to the road a little bit? Will that help? If we can get, we're quick enough. No, 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 no. No, I've done it again. I have missed the click point. No, too late, too late. Nope. Right, let's try and bring it over a little bit more. Try and give us some space so we can operate the car. Okay, that is not doing anything, so there must be something wrong with the script. Control Z. There we go. So there's something wrong, I think, with the code. Aha! That's where I've gone wrong. I'll show that code. Code. So if we look here, I did right, but I also put speed. And it should have been turn speed. So there's my first rookie mistake. Turn speed. There we go. That should fix it. Hopefully. We will try. Code. So let's go ahead and try it out now. We can get hold of the vehicle quick enough. So we're moving. There we go. That's a bit better. No, I went too far over. Whoopsies. Okay. It's all about learning and practicing. So now main 2. So we'll go back here. We will mark that step as done or complete. Base left right movement and on input. Mic will be muted again while the tutorial guide video is playing, so it doesn't echo.
Our player can now drive down the road, and we can change the speed of its movement. We can even change the speed of its turn. However, if our player is actually playing the game, we don't want to be able to fly off the road, for one, but also, if our player is using like a joystick or something, we can't just be dragging this variable around. We can't do this for a single player, like it's magic behind the scenes. So we're going to create some actual magic so that the player can actually control their own movement. A very helpful thing to know before we get into programming this is understanding that Unity does a lot of things that make our lives a lot easier. So, in fact, if you go to the top left under Edit, or if you're on Mac under Unity, if you go down to Project Settings and you click on that, there's all these options for project settings, but what we really care about is actually our input. So this is actually our input manager in Unity, and they've helpfully already created a way where when you do something, it's already mapped to be able to change that value. So if you left click on the drop down on axes, you can see there's different ones, like there's actually fire button, so you can actually press like the left control button to fire something, or a second option, left alt, left shift. There's a jump, which is the space bar. You can take a look at all of these different options, but what we're looking for specifically are actually these horizontal and vertical axes. And so this is actually how Unity knows if we want it to go left or if we want it to go right. Using these horizontal axes, we can actually see those values change and how they change. You can see that there's inputs for the left arrow key to go negative or the right arrow key to go positive. There's also alternative buttons for using the A key to go negative or the D key to go positive, and it's called the horizontal axis. Knowing this, we can do something really easy to be able to control the player's movement. In our player controller class, first we're going to create a public variable so we can actually watch and see what it's doing. And this will be a float again, and we'll call this horizontal input because this is actually the input that we'll be tracking on our horizontal axis, left or right. And then what we need to do is we actually need to set this variable, which we'll do inside of our code. So we'll actually do this in our update method. So we use our horizontal input, we call our variable, and then we use the equal sign. So we're going to assign this variable some value. And now if you remember that input manager, so there's actually a class and a method that we can call just for that input manager. So if we type capital INPUT, so this is our input manager. It's called input. So now that we have our input manager class, if we type dot, and then we were looking for that axis before, so we can actually use our getAxis method. So this will give us the values for when we press the left or right key on that axis, but we also need to tell it which axis we want to use. And in this case, it's asking for the name of our axis, specifically a string. Now, a string is a way for your computer or program to create a word that is literally interpreted by the computer and easily understandable for us. So, for example, if I in here actually type in a double quote, you can see it actually auto-completes a double quote for me at the end. So this is creating a string literal inside of these quotes. So it'll literally interpret anything that I put in. I could literally say hello world, which is very helpful if I'm trying to, for example, print something, or I need the program to tell me an error that's happening or something like that. Using string literals can be helpful in that sense. For this, we actually type in the word horizontal because in Unity, in our input manager, the name of our horizontal axis is just horizontal. So now we're getting the input for whenever a player presses the left or right key. And then last but not least, we need to actually go into our translate and multiply this by our horizontal input. So now if you make sure you save, we can close out of our project settings. And let's make sure we select that vehicle so we can actually see what's happening on the horizontal input. Our turn speed is set to 0, so we know that's not going to work. So we'll set it to 1 for now. And then if we press play, so we should see if we press the left arrow key, it slowly moves to the left. If we press the right key, it slowly moves to the right. And we can use the A key too if we want to use the other key. It'll move to the left. If we use our D key, it will slowly move to the right. So we know our input manager is working. You can even see the values change from -1 to +1. So that's a very handy way of understanding how your input manager works. As you press the left arrow key or the A key, horizontal input goes negative all the way to -1. Or if you press the D or the right arrow key, it goes to +1. So what you're going to do is you're going to add another public float variable called horizontal input. In your update method, you're going to call the horizontal input variable. You're going to set it to the input for our input manager, and you're going to get the axis that's horizontal, so we can get those left and right arrow keys. And then last but not least, in your transform.translate, you're going to multiply the entire equation by our horizontal input. Now it's your turn.
Main code so let's go here. No, we need Unity first. We need to go into Unity code. We need to go in here first. Edit project settings. Input manager. In update, assign horizontal input. In the left sidebar, then expand the axis, bold out to explore the input. Horizontal and vertical, they're the ones that we need. In update, assign horizontal input in update, so that will be the script. Code So in this script, player controller. Then we go up here, public, float, horizontal input, control save, just in case anything happens to the code. Then down here, we do horizontal input equals input dot get axes. Then we do just for simplicity. That's that. That's just if you're testing to see if you're wanting to print something out. Normally you wouldn't do this, but might make it a little bit easy for us. There you go. Copy and paste. Not meant to, you shouldn't really copy and paste in code, but doing it for just to make it a little bit quicker. So then that's saved. Let's do that. Code. And then if we go down here, so turn speed, let's set that to 1. Play. I don't know what it's doing. Oh dear. What's happening? Vehicle. No, why? It's, oh, hang on. What's this? Ay. We've got 9999 plus errors. Whoops. Okay, we need to fix that. Code. So turn speed. Multiply it by turn speed, multiply horizontal input, control save, code, and if we go here, do we need to select the car? I think we do. No, hang on. What's this? Yep, we've still got these errors. Okay. Let's have a look. Code. Let's have a look. In the inspector, edit the turn speed and speed variables to tweak the feel. From the top menu, click Edit Project Settings, select Input Manager in the left sidebar, then expand the axes, fold out to explore the inputs. In Player Controller.cs, add a new public float horizontal input variable. In Update, assign horizontal input equals input get axes by capital H. Code. See if that does anything. That's working now. I must have made a little mistake. Okay. Main 2. So we've done that. We've got the car. Take control of the vehicle speed. Microphone will be muted again during the guide video.
Our vehicle can now move to the left or the right. Looks a little weird, but we'll fix that later. The problem is we keep moving forward, and I want to be able to control that too, just to make it a little bit more interactive. So if we take a look at our input manager again, in the top left, if you click Edit or Unity, go to Project Settings, select the input option, and then make sure to expand the axes. In this case, I'll collapse our horizontal axis. You can see the vertical axis here with the name vertical and uses down for negative, up for positive. So we can do the same thing that we did with our horizontal input and do that with our vertical input. In our player controller script, we're going to create another variable. We'll make it public as well so we can see it. We'll make it a float because we need decimals, and we'll call this forward input to control our movement forwards or backwards. Similar to what we did with our horizontal input, we'll create a new line. We use our forward input, and we're going to set this to our input manager. .getAxis, use quotes to create a string literal, and then we use vertical. And then we will change in our translate method for moving forward. We'll just multiply by our vertical input. Our forward input, I should say. So now in Unity, if we close the project settings and then we press play, we should see, hopefully, our vehicle doesn't move at all. Cool. And then if I press the forward arrow, it moves forward. If I press the backwards arrow, it moves backwards. Same thing with W, moves forwards. S moves backwards. And then I can even move forwards and move to the left at the same time. I can move to the right with the arrow key. I can even go backwards. Make it really challenging for myself. Can't see the boxes. And then we still have this weird issue where our vehicle can move side to side, but we'll fix that later. But we've got player movement down. So that's really handy. Now we can give our players full control of our game. An especially cool thing to note about the input manager is that this can actually understand input from a variety of different places. So for example, if your player was using a controller, then you can actually get the input, for example, from their joysticks to know when they're moving to the left or right, or forwards or backwards. So the input manager is a very helpful way to be able to get information from the different kinds of input, whether it's a keyboard or it's your mouse or it's a controller, different things to make your life a little bit easier. So, what you're going to do in your player controller script, create a new variable, a public float variable called forward input. In your update method, you can add a new line of code similar to our horizontal input. We'll call it forward input, and we make sure to get the axis of our vertical axis. And then in our transform.translate, where we are moving forward, we'll just multiply everything by our forward input. And then in Unity, when you press play, you can test out your movement in your vehicle. Now it's your turn.
Main. Code. That should be good. I'll test it. Code. Let's have a look. Double check I've saved it. Yep. Why is the vehicle still moving? Oh, I know what I've done. Again, I've made the same rookie mistake. Code. I made the same rookie mistake twice, maybe 3 times. So we're multiplying that with forward input, horizontal input. Yep, that should be fine. Control save. Code. Go here. Play. The vehicle's not moving, so that's a good sign. So, go with 15. Horizontal turn speed. Go with 3. go. Save the project. Main 2. You can go ahead and mark as complete. Make vehicle rotate instead of slide. Before we go any further, be right back. I'm going to go and I'm going to go and make myself a hot cup of tea or coffee, whatever. And then once I've done that, we'll come back and we will continue our little project.
Chat commands are on screen.
You stupid boy don't know that law always wins. They already broke open the door.
Throw that paper, 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 throw that paper. 10, 20, 50, flicking hundreds, flicking hundreds. 10, 20, 50, flicking hundreds, we flicking hundreds. Get the ambassador, mellow philosopher. You may have to adjust your camera aperture, cause I'm the man with the plan that's been planning to take over the planet like a dictator, get paper. Let your inhibitions go, time to advance. This is what I came to do. Freaking out, body shaking, get about your stance. This is what I came to do.
The fire's getting stronger. You don't have a chance. Here comes the end.
My neck cold, frozen ice. My neck cold, frozen ice.
Something exquisite, like visiting foreign lands for more than business. What is this? I dig this, son. It's a lot more like abstract, but I went way past that. Oh no, just look what that got me to. Is he going in? Is he going out? Easy come, easy go, what it's all about. Mama putting in work, she gon' get it out. In the club on the floor, she gon' work it out. Is he going in? Is he going out? Easy come, easy go, what it's all about. Mama putting in work, she gon' get it out. In the club on the floor, she gon' work it out. Paper, throw that paper, paper, throw that paper, paper, east, west, north, throw that south, paper, stacking paper money makers in the house. Paper, throw that paper, paper, throw that paper, 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 throw that paper, throw that paper, paper.
There's a killer working on the dance floor. Yeah, it's gonna get you if you just move on. There's a killer waiting on the dance floor. Yeah, it's gonna catch you, just leave me alone. I'll never stop, no, I'll never stop. I'll never stop, no, I'll never stop. There must be a road that I can take.
Mic's playing up. There we go. Mic's working now. I had to smack it. Well, not smack it, but tapped it. Main. So we got up to the point where we got the vehicle moving with the W and S, arrow key up and down, arrow key left, right, D, A and D. So that is working as intended. So let's go and switch to main 2. Main 2. So now we are going to look at make vehicle rotate instead of slide. Microphone will be muted. Just letting you know.
We have full control over our vehicle now. It's not just driving off down the road, but now we have some weird stuff happening. So when we press the left arrow key, we slide to the left. And if we press the right arrow key, we slide to the right. To visualize again what we're trying to do, I'm going to go into my top-down view by clicking the green Y arrow in my scene view, and now I'm very high up in the sky. If I select my vehicle in my hierarchy and I press F while my mouse is hovering over the scene, we focus back into the vehicle. Now I'm actually going to select my rotate tool. So let's see what's changing actually when we click on this circle here. If we drag it to the left, you can see in the inspector underneath transform, the Y rotation is actually the thing that's moving. So that's probably what we'll want to change in our code. In our player controller class, we already have this bit of code here where we're moving left or right. Let's see, well, if we are using our vehicle's transform, then we'll need that transform component. Now let's see, luckily, because my IDE suggests different methods that I can use, well, there's this one method called rotate, so it'll actually rotate it at an angle. Well, let's just see what it does. So if I click on the rotate method, and then I type an open parentheses, it suggests different things. So it wants a vector 3, Eulers, an axis, and a float angle. That one seems pretty useful. Well, we know that the axis is that y-axis, that vector 3 up. So actually, vector 3 dot up. And then it wants the angle. Well, we kind of already calculate an angle here because of our turn speed. Let's just see what it does. So if we select our time all the way down to our input and our vector 3 dot right translate, if we cut that out with Control or Command X, in our rotate method, after the comma, make sure to paste that entire line of code in there. We're going to put the semicolon to close that statement, and then we just delete our translate there for vector 3 right. Now if we save, we'll see if that works, if that was what we're looking for. Now when I press play, if we watch the vehicle in our game, as I drive forward, I'm turning left and I'm turning right ever so slowly, but I'm turning, so that looks pretty good. So what we'll actually do is, if we select our vehicle in the hierarchy, we'll turn the turn speed up to like 25. We'll see what happens. We're just testing anyways. Now we'll play again. There you go. Now it looks like our car is really driving down the road. That's awesome. Look at it go. Just driving all around, avoiding all those obstacles. One very cool thing to note. So, in fact, if I actually go in my scene view, and I'm going to keep play on here just so we can kind of see what's happening. So you can see in our game, as I move forward, it always knows what direction it's moving forward. Now, we've been moving all of our objects in our scene, if we select our move tool, based on the global position of things. So we're always doing it based on 0, 0. Our Z arrow will always go positive in the Z. Same thing with our X arrow and our Y arrow. But at the top left, next to all of our tools, you'll notice this button here that says global. In fact, if we actually click on global, we can set this to local. Now, let me get a better angle so you can kind of see what's happening. So as I turn the vehicle, nope, make sure you have the game selected. As I turn the vehicle, you can see that the Z is changing and it's always pointing in that forward direction. But then if I switch this toggle back to global, you can see that the Z flips back to the positive Z direction of our world. So when you're trying to position things in your world, it's helpful to have that toggle set to global. But then when you're testing things, like if you want to make sure that your object is facing the right direction, you can toggle it to local, and then you can see which way your object is pointing while you're trying to interact with it. So that's very handy. Very helpful tip in case you ever need it. So what you're going to do is in your player controller script, down where you were transform.translating by vector3 right, you're going to create a new line of code underneath it, and we're actually going to use our rotate method on our transform component. We need the axis that we're going to rotate it around, which in this case is our up axis. And then we need the angle that we're going to turn it at. So we need to make sure that we're calculating it based on time instead of every frame. We just multiply by that turn speed, and then we multiply all of that by our horizontal input. And then when I save back in Unity, you can select your vehicle, play around with the turn speed and the speed, so that way when you're pressing play and you're testing your game out, you can see how fast you're turning and how fast you're moving. And you can set it to whatever feels good to you. Now it's your turn.
Main code. Da, da, da. Code. So that is working. Main 2. Mark completed. Clean your code and hierarchy. Step 5. Microphone will be muted.
Now our game looks really good. Our player has full control. We got rid of that weird turning issue we had. So now we can actually just turn instead of sliding around the road. So what we're going to do, last but not least, is we're going to clean up our entire project so that it's nice and organized. Luckily, we've done that already in our project window with all of our folders. We have our scripts and we have our assets in our library. We have our scenes, so we don't have to worry about any of those. There is one bit of cleanup here in our hierarchy. We have all of these obstacles, and that's kind of disorganized. It also will clutter up your hierarchy very quickly. So we can actually take a tip out of our environment here. So you can see actually there's 3 other objects under our environment for our road, our sky dome, and our mountains. So what we're going to do, we'll collapse our environment. If we right-click on the hierarchy window, we can scroll down to create empty. So this will actually create an empty game object in our scene that we can't see. It doesn't exist. If I click off of it, there's nothing actually there. If I click back on the game object, there you can see it. So we'll actually rename this obstacles, and I'm just going to select the name in the inspector. Rename it obstacles, press enter. So we can use empty game objects to just keep track of all of the different groups of objects in our scene. In this case, I'm going to select our first obstacle, shift click to the last obstacle, left click drag all of those into that empty game object. So now all of those game objects are nested underneath that empty object. Later, we'll be able to really use nested game objects to their full power, but at the very least, we can use nesting of game objects, so our parent empty game object can just group together all of our children game objects so that our hierarchy is nice and organized. So if I collapse this, now it looks a lot cleaner, but if I ever want to go see all of my obstacles, I can click on the arrow next to it, expand, and see all the different obstacles that are there. So that's super helpful. Now, we're going to clean up a lot of the code in our player controller script. So first, we don't need these public variables anymore. We already know the values that we want to use. So we'll make them private. That way, whatever we change inside of the inspector doesn't have a different value inside of our script here. One thing we do need to do, we never actually set turn speed, so we'll need to initialize that. So I believe we had something like 25 or so. We can always change it later if we need to. We can even add some comments, so private variables, so we know that this is where all of our private variables are. In our update method, we can also add some comments. So we can add, this is where we get player input. We can change this comment because we did make the vehicle move forward. And we can add another comment underneath. We turn the vehicle. And then we save. So that way now our code is a lot more readable, very organized. We know exactly what we were trying to do. And then if we want, we can do the same thing for our variables in our follow player class. In this case, we're going to keep our game object public because we actually gave this variable a reference in our script in Unity. So if we actually turn this to private, we won't have that reference anymore and we'd actually break our camera. So what you're going to do is in your hierarchy, if you right click inside of it, you can create an empty. So it'll create an empty game object that has no real information inside of it. Doesn't really do anything. You're going to click on it and you can right click and rename, or you can click on the name inside the inspector to rename it to obstacles. You're then going to select all of the obstacles in your scene and you can drag them into the obstacles empty game object. That way they all nest underneath, they're all stored underneath the obstacles game object. So that way it makes our hierarchy a little bit cleaner, easier to manage. It becomes very important if you ever have hundreds of different things in your scene. Organization makes it very easy to see and find what you're looking for. And then in our player controller script, we're definitely going to change all of our public variables to private because we don't need them to be public anymore. And we can add in some comments so that we know what we did. So we made some private variables for ourselves. We made a note about this is where we're getting our player input. We moved the vehicle forward. We turned the vehicle. Now it's your turn.
Main. Code. So here I've already changed some things. The only thing I haven't done yet is the public. Now I'm wondering, find and replace, public, private, hang on, public, private, go back, replace all, I think that was meant to be public regardless. Could be wrong. Let me just double check. Yeah, everything else was set to put private apart from the top line. No, yep, player controller. No. Transform, rotate, vector up to I'm just double checking everything. So that's that. Code. Now we add create empty. Ob obstacle. Goes in there. Think we've got this. Just double checking everything. Wait, that code. So what I've done is I've replaced that text. Void update. Yeah. So save that just in case. Code. And if we go back to the hierarchy, go back to the game, it should still work. Go. Mark as complete. And then lesson recap. Main 2.
We finished off all of the functionality of our game now, so our player has full control over this vehicle. When we press the up arrow key, the vehicle drives forward. If we press the right arrow key, we turn right. If we press the left arrow key, we turn left. We can even press the down arrow key to go in reverse. So now we have a lot of amazing control. We learned a little bit about empty game objects so that we can use it to keep our projects organized, like in our environment game object, storing all of our different environment assets, or our obstacle game object, keeping track of all of our different obstacles in our scene. We also learned all about using the input manager to get input from our player, in this case when they press the up or down arrow key or the left or right arrow key using our forward input and horizontal input. And then we learned about a new method that we could use, in this case our transform.rotate method, so that we can actually rotate the vehicle against a certain axis instead of just translating the vehicle, which looked really weird. Overall, we've come a long way down this road, starting from absolutely nothing to creating our very first Unity project. We even reorganized our window. We added some colors so we can see when we're playing our game. We created our very first game objects and assets and added them to the scene. We learned all about scripting. We even made 2 scripts and wrote our first lines of code to be able to program this vehicle and drive down the road. So, with that, you should feel super proud of yourselves for making it all the way to the end of the road. And we'll see you in the next project. Welcome to Challenge 1. Now, if you remember in our first project that we made, we added a lot of functionality to our project with this vehicle that can drive forward and these boxes that have physics and collisions in it, and we can fully control this vehicle, turning it left and right, driving it forwards, driving it backwards. So, for our first challenge, you can see that we have this plane flying game, and if I use the arrow keys, I can control it going up and down. Our plane is flying forwards at a nice, consistent speed. We have our camera over on this nice side view so we can see our plane flying around and we can fly through all these obstacles, and we're following the plane really nicely. So, this is what our challenge should look like by the end. And this is what our project looks like now. Oh my gosh, the plane just flew straight backwards. It's like, it just keeps going incredibly fast. That's far too fast for us to be able to do anything. Oh my gosh, just flying straight up all the way directly into the air. Well, that's not good. Can I even control this? No. That's really frustrating. For some reason, our camera also has this weird front view, and it doesn't even look like we're following the plane at all. I don't even know where the plane is. It's gone. That's frustrating. Okay. Now, on our challenge page, below the video, you can see that there's all of these different steps that we can go through to make our project complete. You can see here listed the entire step that you have to do. So the problem is the plane is going backwards. What we need to do is make the plane go forwards. And if you get stuck, there are these helpful hints at the bottom of each step to help provide you with a little bit of insight as to how you can fix the problem in case you get stuck. Our next step, the plane is going too fast, so we need to slow it down. The camera is in front of the plane, so we need to reposition it. Our camera is also not following the plane at all, which isn't very helpful. And our plane is tilting automatically. So, in order to get our project to a complete state, we need to make sure that we go through each of these different steps. And something helpful that you can do as you complete each one, for example, if you finish watching this video, you can mark the step as completed. And then if you fix the plane going backwards, you can mark it as complete. If you found you actually broke something, you can mark it as incomplete so you can keep track of your progress. In addition to our main problems with our project, we've also added in bonus challenge problems that you can try and solve to see what you understand about Unity and push your knowledge just a little bit further. So, in our completed project, you can see if I press play, and then I'll just pause this game really quick. And then actually, if I go focus in on the player, we'll get it to the side. And I'm going to step through, and if you watch the propeller, you'll see that the propeller actually rotates as the game is playing. So that's a cool, fun little feature that you can try and do yourself. The bonus challenges are designed to be a bit more difficult than what you know and understand. There are hints that help you along the way in case you want to give it a try and see what you can do. In addition, if you do get stuck, feel free to use the internet. There are so many different resources that you can use just looking it up on Google. So for example, if I want to figure out how I can make an object rotate in Unity, there's a little tutorial that you could do for spinning a cube that's very similar. Somebody asked a question on Stack Overflow about rotating an object that might have some good advice on how you should approach it. This is kind of an interesting one. How do I rotate an object around its center in a script? Very similar to what you're trying to do. In addition, these challenges are also a great opportunity to take a look at the documentation. So here is actually the documentation about how transform.rotate works. That goes in depth about all of the different ways that you can use the rotate tool and the rotate method. It even has some examples that you can take a look at. So if you want to see different ways that you can rotate something, it's a good place to go. And you can also see all of the other different options. For example, vector 3, of all of the different vector 3s that you could potentially use. So that way, you can start digging a little bit more into all of the different ways that you can use all of the different methods and the different classes in Unity to be able to create your projects. In our starter project, you can see that when I press play, and hopefully if I can pause really fast, all right, I hope our player, they're out in the distance, so I'm just going to focus in. So you can see if I step through, hopefully the plane stays in view. The propeller is never actually moving. So that's a problem. Now, if you do get stuck, inside of your challenge folder, there's a set of instructions that you can use. And inside of the instructions, if we click on the challenge 1 outcome, and in fact, in our inspector, you can see this little gray bar down here. And if we actually just drag this up by clicking on that gray bar, you can see there's actually this little video. And if you press the play button, you can see exactly how we were trying to make our plane and our game work before. Now, a lot of the things we were trying to do before are very similar to how we set up our initial project that we made, our prototype 1. So if you ever get confused or get lost, you can feel free to reference your prototype, take a look at your scripts, see the different things that we set up in our scripts to understand what's going wrong inside of our challenges. Another really helpful thing in our challenges is in the scripts folder. All of the scripts actually have an X at the end of the name, so that way you know that this is our challenge script versus the names of the scripts that we had before. To get started, download the challenge assets using the link below the video. It will prompt you to download your challenge file, and then if you want to add that asset package to your project, you can go to the top left of Unity, click the Assets button, Import Package, Custom Package, which will then bring up your File Explorer, and then just go to the folder where you have that package saved, click on it, click Open, click on the Import button when it gives you the prompt on the window, and it will download that package to your project. So, get started on your first challenge, and good luck.
Okie dokie, we are on our first challenge with Unity C#. Open your project type 1 project. Download the Challenge 1 starter files from the Tutorial Materials section, then double-click on it to import. In the project window, Assets, Challenge 1, Instructions folder, use the Challenge 1 outcome video as a guide to complete the challenge. So, main, so we are going in here. Let's save this. Let's minimize this. Assets. No. Assets. Import custom. We don't have that file. Where is that file? Tutorials mission. Ah, okay, I think they are talking about the hub. Learn. I think. Download the Challenge 1 starter file from the Tutorial Materials section. No. Tutorial materials. So it's actually on the challenge main 2. it should be down here. Yeah, here we go. Challenge 1. Let's cut. Paste. Extract. We got our challenge 1 file. Main. And then if I go into our Unity assets, no, edit, no, where is it? Assets. So for anyone who has just joined, if you just joined, we are doing our first challenge. So we'll go here. This is our challenge 1. And then if I bring you guys over, main 2. Main 2. So it says here, warning, when you import the challenge into your project, it is supposed to have bugs The purpose of the challenge is for you to fix those bugs which are listed below. There are also hints at the bottom of the page to help you if you get stuck. If you cannot fix the bugs and wish to delete the challenge files from your project, in the project window, right-click on Assets, Challenge 1 and select Delete. Good luck. The plane is going backwards. So, bring this over. Main. So when we play this, the plane's going backwards. Now it is going to have bugs, like they said. Make the plane go forward. So we have got to find, I think it will be under scripts. Let's have a look. That's scripts. So the plane is going forward. Okay. I think it would be under player controller. Save all. Close these. And then if I go to here, code. And then what we will do, we'll go in here, open file, challenge 1 scripts, open up player, follow player, and we will also open up follow player and then player controller. So let's have a look. Object plane, private vector 3 offset. Transform position plane offset. Okay. Speed, rotation, speed, vertical input. Vertical input, get axes vertical. So I think that needs to be forward. So that, I think that's one bit we needed to change. That's one part of it anyway. Code. Let's have a look. Yep, the plane's going forward now. Code. So we've got the plane going forward. Follow player. So we've got that transform dot position equals plane dot transform dot position plus offset So I think we need to change this line. So I think that should be equals 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 new vector 0 dash something x and y. Let's have a look. X and y. So where is the main camera? Where is well, no, we can't really have it behind, can we really? Because we need to see it sideways. Wait, hang on. Oops. This player controller. I just had to pop away for a minute just to help my mom with something. So if you just joined, we are doing our first challenge. So basically bug fixing. So what I've done is I have downloaded, let me just code. So I have downloaded a an asset from the Unity Hub guide before the plane was going backwards. I've got it going forwards, but we've also not got the propeller isn't, you know, like rotating. And now I've got to figure out the so in my previous prototype 1, I believe we had to move let's just double check. So we've got the player controller. So we need the follow player script to go in the main camera, if I remember correctly. No. Wait, hang on. Game object will be the plane. So we've got to sort of work out the controls for the game. Player controller. So let me do this. Code. So player controller. Vertical. I think vertical is the y-axis, if I remember correctly. Y-axis? Vertical? Yeah, y-axis. So I have got to try and do this. Transform dot translate vector 3 forward plus speed. Tilt the plane up down based on up down arrow keys. So let's code. Let's go here. Rotation speed. The rotation speed, is it? Rotation. I should probably move the camera a bit further back. So it's up and down keys. So up and down keys aren't anything. That needs to be plain. Code. So doesn't it need to be No, we're not using horizontal. Horizontal goes left and right. Code. Is it on here? No. Assets. Edit. Vertical. We made the plane go forward. This is what I'm looking at. Main 2. So this is what I'm looking at. So we've got the plane going forward. Now the plane is going too fast. Slow the plane down to a manageable speed. Main. Code. So the speed so what we do, let's have a look. Let's look. So we go here. I think it's equals. Let's go with 20.0f because it's a float. Code. We should probably 15. Rotation speed. Rotation speed. Code. Rotation speed. So I think rotational speed equals 10.0f. Code. So what is the plane actually doing? It's rotating this way, like that. So the rotation moving on the the x-axis. Code. So we need to input. Why is I honestly don't think they're meant to be there. Code. So what we're actually trying to do, let me show it on the screen. So what we're trying to do is we're trying to get the plane to do this. That's what we're currently trying to get to work. Speed 15. There is 5. So up here, the X, Y, and Z on the rotation are moving as well, along with the X, Y, Z position. Code. We set that to 5. Let's change that to 2, see if it does anything. Code. I've really messed that up, haven't I? Code. We need to do something with that vertical. Code. Oh, no, that is now going around in circles. Rotation. Um, let's try left. Try left. See what happens. Nope, definitely not. Nope. So if you just joined, we are doing a challenge. We will show you right now. Main 2. Don't worry about that. So we've currently got the plane going backwards, but we've got it, we've made the plane go forward. The plane is going too fast. I've played around with the speed a little bit, so we could probably mark that. The plane is tilting automatically. Make the plane tilt only if the user presses the up-down arrows. Main. So we are currently bug fixing. That's what it's known for. That's what it's known as. We don't want to do that. So that's what we're doing at the moment. Code. Go. It will do right again. Code. So right makes us go that way. So I'm currently trying to bug fix this challenge. because the plane is only meant to rotate when the player presses the up and down arrows. Code. Because we got the rotation speed, the vertical speed. So we got that forward because that said back. But the up and down based on up and down arrow keys. What if code? What happens when we do this? That's definitely not that. Code. So you need to. The plane is moving automatically. The plane is tilting automatically. Make the plane tilt only if the user presses the up-down arrows. Why is that? Oh no, that's wrong. So code. Right, so we've got right down. Try that again. No, still not right. You need to get it up and down. Let's try putting right. Try putting right. Ah, I think I've got it working. So we got right. Didn't really need it that close. Try that. We're too close again.
The tally's gone dead again.
Now it's going up. So we've sort of got it working. But it's still trying to pull itself back down. Hmm. Code. Mm. Mm. So it's definitely something with this rotate line. Gotta be something to do with this rotate. Code. No, definitely not that. Code. So it's definitely not that. So it's using rotate. Does rotate around? What is that? Hmm. Nope. Still not doing what it is meant to be doing. Make the plane tilt only if the user presses the up-down arrows. It's not going to be up. Nope. Okay. Code. Code. Hmm. Hmm. Main 2.
Welcome to Challenge 1. Now, if you remember in our first project that we made, we added a lot of functionality to our project with this vehicle that can drive forward and these boxes that have physics and collisions in it, and we can fully control this vehicle, turning it left and right, driving it forwards, driving it backwards. So, for our first challenge, you can see that we have this plane flying game, and if I use the arrow keys, I can control it going up and down. Our plane is flying forwards at a nice, consistent speed. We have our camera over on this nice side view so we can see our plane flying around and we can fly through all these obstacles, and we're following the plane really nicely. So, this is what our challenge should look like by the end. And this is what our project looks like now. Oh my gosh, the plane just flew straight backwards. It's like, it just keeps going incredibly fast. That's far too fast for us to be able to do anything. Oh my gosh, just flying straight up all the way directly into the air. Well, that's not good. Can I even control this? No. That's really frustrating. For some reason, our camera also has this weird front view, and it doesn't even look like we're following the plane at all. I don't even know where the plane is. It's gone. That's frustrating. Okay. Now, on our challenge page, below the video, you can see that there's all of these different steps that we can go through to make our project complete. You can see here listed the entire step that you have to do. So the problem is the plane is going backwards. What we need to do is make the plane go forwards. And if you get stuck, there are these helpful hints at the bottom of each step to help provide you with a little bit of insight as to how you can fix the problem in case you get stuck. Our next step, the plane is going too fast, so we need to slow it down. The camera is in front of the plane, so we need to reposition it. Our camera is also not following the plane at all, which isn't very helpful. And our plane is tilting automatically. So, in order to get our project to a complete state, we need to make sure that we go through each of these different steps. And something helpful that you can do as you complete each one, for example, if you finish watching this video, you can mark the step as completed. And then if you fix the plane going backwards, you can mark it as complete. If you found you actually broke something, you can mark it as incomplete so you can keep track of your progress. In addition to our main problems with our project, we've also added in bonus challenge problems that you can try and solve to see what you understand about Unity and push your knowledge just a little bit further. So, in our completed project, you can see if I press play, and then I'll just pause this game really quick. And then actually, if I go focus in on the player, we'll get it to the side. I'm going to step through, and if you watch the propeller, you'll see that the propeller actually rotates as the game is playing. So that's a cool, fun little feature that you can try and do yourself. The bonus challenges are designed to be a bit more difficult than what you know and understand. There are hints that help you along the way in case you want to give it a try and see what you can do. In addition, if you do get stuck, feel free to use the internet. There are so many different resources that you can use just looking it up on Google. So for example, if I want to figure out how I can make an object rotate in Unity, there's a little tutorial that you could do for spinning a cube that's very similar. Somebody asked a question on Stack Overflow about rotating an object that might have some good advice on how you should approach it. This is kind of an interesting one. How do I rotate an object around its center in a script? Very similar to what you're trying to do. In addition, these challenges are also a great opportunity to take a look at the documentation. So here is actually the documentation about how transform.rotate works. That goes in depth about all of the different ways that you can use the rotate tool and the rotate method. It even has some examples that you can take a look at. So if you want to see different ways that you can rotate something, it's a good place to go. And you can also see all of the other different options. For example, vector 3, of all of the different vector 3s that you could potentially use. So that way, you can start digging a little bit more into all of the different ways that you can use all of the different methods and the different classes in Unity to be able to create your projects. In our starter project, you can see that when I press play, and hopefully if I can pause really fast, all right, I hope our player, they're out in the distance, so I'm just going to focus in. So you can see if I step through, hopefully the plane stays in view. The propeller is never actually moving. So that's a problem. Now, if you do get stuck, inside of your challenge folder, there's a set of instructions that you can use. And inside of the instructions, if we click on the challenge 1 outcome, and in fact, in our inspector, you can see this little gray bar down here. And if we actually just drag this up by clicking on that gray bar, you can see there's actually this little video. And if you press the play button, you can see exactly how we were trying to make our plane and our game work before. Now, a lot of the things we were trying to do before are very similar to how we set up our initial project that we made, our prototype 1. So if you ever get confused or get lost, you can feel free to reference your prototype, take a look at your scripts, see the different things that we set up in our scripts to understand what's going wrong inside of our challenges. Another really helpful thing in our challenges is in the scripts folder. All of the scripts actually have an X at the end of the name, so that way you know that this is our challenge script versus the names of the scripts that we had before. To get started, download the
Hang on.
asset.
Danesh. Sorry if I spelled it wrong. Welcome to the stream. Just a quick overview of what we've actually got at the moment. Let me go here. Main. Don't worry about this for now. What I'm going to show is our first project when we was learning how to use Unity. We made a little prototype. So when I play, we can. This is with WASD. But now that we've got past that stage, we are now on a challenge where we have to try and get this plane to not do this. We have to get it to where it only works when the player presses the arrows, the up and down arrow input to get through the obstacle. So if we go back over to let's do this main 2. So this script that you're looking at on your screen right now is the plane, and we have got to try and fix the bug where the plane should only tilt when the player has pressed the up or down arrow. So I am trying to figure out what I need to do to do this. If I go into one of my scripts, we're looking at, so this script is the prototype that you've seen. This is our little moving the vehicle about, where you've got your, like, this is where the player input is, horizontal and vertical. Then you've got the vehicle forward, so we've put forward in, so it moves with the WASD and also with the up, down, left and right arrows. And then we have also got a turn speed. So I have got to now try and get this aircraft to only go to tilt up and down only when the player presses the up and down arrow keys, like I'm doing now. And I'm trying to figure out how to do that. And that's why I'm re-watching the tutorial, so you understand the challenge as well. So we've already imported the asset. We have got the plane going forward, sort of, not backwards. The plane was going too fast, so I had to slow it down to a manageable speed. And now I'm trying to figure out this. The plane is tilting automatically. Make the plane tilt only if the user presses the up and down arrows. So I am trying to debunk, I should say, the code for the aircraft. So if I was to change that to down, now we might have to redo the whole. I hope we don't really have to redo the whole script, but if we go here, code, no, main, there we go, code. Right, so that turns that off. So so if you remember, we changed the vector 3 dot down of the aircraft. It's now going that way. If I was to change it to left, save the script, it will update in the hub, in the Unity, and then we play, it's going to go that way. We go, I think we did right, I could be wrong, but we'll do right. Let that update, and then that is right. And the idea is to try and get the aircraft to go up and down. As the video shows down here, if we can somehow pull it up. Oh, hang on. Wait. There is a way to pull that up. Now, I don't know how to do this. Let's reset to default mode. Now, instructions, challenge. And then if we look down here, this is what our aircraft is meant to be doing. Going up and down, basically through the obstacles. And that's what I'm trying to figure out. But those game engines will be a better CJ choice. So yeah, that's what I'm currently trying to work on. And to be quite fair, I have messed up my prototype player controller script a little bit, which I think I only need to change the turn speed. So let's go here. Let's load that vehicle. Where is it? Turn speed. Where is that? Where is math? Is it no? No. There's a road turn speed somewhere here. So we need to change that back to what it was at some point. But we are doing our first challenge. Yes, I am going to try my best. I don't know if I'm going to get anywhere at the moment because I'm trying to figure it out. So yeah, it might take a bit of time till we can actually get it to work. I'm going to end the stream here. I've been live for 5 hours. If you did enjoy, then please like, subscribe, turn on post notifications. Make sure you turn all notifications on. And off stream, I'm gonna still keep trying to get the aircraft to work properly. So yeah, I will catch you all in the next. I'll catch you all in the next stream, hopefully. Ending.